We're going to be creating a stock screener together in Python. The goal is to create a trading algorithm based on technical analysis criteria plus analyst ratings. Then see which stocks the algorithm performed better compared to the stock itself to generate alpha. Then provide a list of stocks to buy and sell today so that we can take action. So let's review our strategy. This trading algorithm will use mean reversion plus momentum plus analyst ratings to decide whether or not to buy, sell, or hold a stock. We will backtest the algorithm using mean reversion plus momentum to capitalize on the law of averages and trends. The algorithm will do a final filter to return stocks with bullish coverage to buy and bearish ones to sell. After doing the necessary Python import packages, we're going to use wikipedia.org. They have a convenient list of all the S&P 500 companies. We're going to create a variable called URL, and this is going to be updated automatically because once Wikipedia's list is updated, our list is also updated. So this is an automated method for us to get all the tickers in the S&P 500 in a neat list. Once we create the algorithm, we're going to run the algorithm through this S&P 500 list to have an exhaustive results list to see which stocks we should buy and sell. We need to derive some technical analysis to support our algorithm. So we have mean reversion plus momentum. For us, this means when the low of the day is less than the Bollinger Band lower, and the RSI is less than 30, or the money flow index is less than 20, then buy. Essentially, we see that the price is exceeding the mean reversion and there's oversold momentum. Simultaneously, when mean reversion is high and the momentum is high and we're in overbought territory, then we sell. We're going to use Bollinger Bands for the mean reversion and then the RSI plus MFI, which are popular oscillators for momentum. The formulas are here for reference. We're going to do a backtest of 5 years. So first, we need to get today's date and call it end, and then the start date is going to be today's date minus 5 years ago. We can create a custom function for Bollinger Bands. It's going to take 2 arguments, data frame and the window size. We're going to use SMA for the Bollinger Bands. We're going to take the close price rolling mean and then calculate the standard deviation of that window. And then we can calculate the upper band and lower band by taking the SMA and adding the standard deviation multiplied by 2. We can return the data frame to return the lower and upper band columns that we're interested in. We're also going to create the RSI. We can do this by taking the difference in the close price, separating the gains from the losses, and then calculating the average gain and loss experienced within a 14 window. The create RSI is going to also take 2 arguments, the data frame and the window size. We can calculate the relative strength by taking the average gain divided by the average loss, and then the RSI value is the RSI formula. Create a new column called RSI, store the RSI value in there, and return the data frame like previously. Money flow index is an oscillator that ranges from 0 to 100. It is used to show the money flow, an approximation of the dollar value of a day's trading over several days. So compared to the RSI, the money flow index is weighted based on volume. So we're going to do a blend of the RSI and MFI. So we could create a custom function for the money flow index. We have a data frame and a window. The typical price is the average between high, low, and close. We can take the raw money flow, which is just typical price, multiply it by volume. And then we're going to do positive and negative flow, kind of similar to what we did for the RSI for the gain and loss. We're going to do another window 14 to stick with RSI. And then the money flow ratio is the positive money flow divided by the negative money flow. The calculation for the index is relatively the same compared to RSI. Create a new MFI column and store the MFI data within that column. Return the data frame. Now here's the fun part where we code the trading algorithm's logic. We're going to download Yahoo Finance data and then use our custom functions that we created to calculate Bollinger Bands, RSI, and the money flow index. Next, before we for loop through each and every day, we're going to initialize variables to store the columns of interest. This is going to be SMA, upper and lower bands, RSI, and MFI. Then we're going to initialize a buy signal, sell signal, and action lists. Now we're ready to for loop through the data frame. This for loop is going to act as if we're going through each and every day, and the algorithm is going to decide whether to buy or sell the stock based on the conditions that we give it. So the I here is the row that we're in, and then the length of the data frame is denoted with len df. The buy logic for this algorithm is going to take the mean reversion and the momentum into account. So first, we want the low value of the day to be less than the Bollinger Band low, SMA 20. This means that the stock price exceeded below the Bollinger Band lower, supposing that the mean reversion has been exhausted and the stock should return towards the mean. Next, we want to also consider momentum. If the RSI is in overbought territory, which is less than 30, or if the MFI value is also overbought, which is around 20, we're going to say 25 in this case, then sellers might be exhausted and the stock may be having a rebound. Now we're going to do the opposite for sell logic. If the high value of the stock is up, that might mean that the buyers have been exhausted and the stock price may revert back towards the average. And then the RSI might be overbought along with the MFI. Now we also want to provide values for our scatter plot in the future. So our buy condition, if that's true, we want to store the buy signal within our buy signal list, similar with sell conditions. And then if there's a hold, we should put a np.nan value into both the buy signal and sell signal, since hold means we do nothing. We're going to store these new values into the data frame as new columns for buy, sell, and action. Now that we created our algorithm, we need something to test our backtest against. We can do the buy and hold method to see if the algorithm outperforms the bought and hold method. So to do this, we can initiate our cash position of $10,000. The position we initialize at 0 because at the beginning we hold no stock. And then the portfolio value can be a new list. And this is where we can track our portfolio value over time. For the bought and hold value, we can just calculate how much stocks were valued at by taking the first value of the open column and then seeing how many shares we could buy with $10,000. And then we just multiply close to the number of shares that we can afford with $10,000 and just hold it until the very end. Now we can iterate through the rows and see what our algorithm would do instead. So we can say for I in range, and then say what is our action and what is our price by using iLock. And then if the action is to buy, then we're going to use the exhaust of our cash. So we're going to buy as much as we can with the available cash and store that amount in position. And then change and update our cash to 0. If the action is to sell, we're going to first check if we have a position to begin with. If we do, we're going to sell out of that position and store that new cash value into our variable cash. And then all the stocks have been sold, so our position is now 0. Finally, we can calculate our portfolio value by taking cash plus position times it by price. Store that new column in a data frame column for portfolio value, and then return the data frame. For example, we could look up 3M. We could use ticker MMM, and then we see that the technicals have came through and the algorithm along with the bought and hold value are present in the data frame. Now we want to visualize our algorithm, see where we bought and where did we sell. We can use Plotly for subplots so that we can see the candlestick chart along with the RSI and money flow index. So we can use the candlestick function and feed it the open, high, low, close to get the traditional candlestick chart, along with a scatter plot overlay so that we can see the SMA lines, upper band and lower band values, along with the buy and sell signals. The buy signal will be a upward triangle. The sell signal will be a down-facing triangle. Finally, the second and third row of the plot will show RSI and MFI at the bottom. And then we could do fig.show. We could zoom in and out to see how our algorithm operated throughout history. Now let's see how the algorithm performs over all the stocks in the S&P 500. We're going to initialize a dictionary to store the results in, and then say for ticker and S&P 500 tickers, we're going to try and fetch the data by using our algorithm function. And then to see whether or not we want to hold this stock into the future, we're going to use the Wall Street analyst recommendations. We can do this by using the Yahoo Finance ticker function and then using stock.recommendations to see what analysts on Wall Street are saying. The algorithm can be performant in the past, but of course, past results are not indicative of future results. So we can use analyst projections to see whether or not we want to hold this stock into the future. We can calculate how many buys each stock has and the sell signals. To dictate whether or not we should buy or sell this stock, we can say whether or not if there's more buy signals. We can do that by basically saying count buy is greater than count sell. If that's true, great, we should maybe look into it. If it's not, maybe we don't want to own it. We can create a new column that says is more buys, and then a yes flag if it's true, or a no flag if it's not. And then finally, we're going to store all that into our dictionary. And then we can run it, and we can see that the for loop is running through all of the stocks in the S&P 500. We can create a final data frame called DF results. This is going to store our algorithm performance alongside the bought and held strategy to see which one outperformed. It's also going to store the analyst buy and sell recommendations to see whether or not we would want to hold this stock going into the future. We can also create a data frame buys, which is only going to house the stocks where there's more analysts saying buy and our algorithm outperformed the stock itself. We can also do the opposite and do DF sells. We can print the results of the DF results table and see the table in its entirety. From the results, we can see that HAL was a great stock for this algorithm. The bought and held strategy turned $10,000 into $16,000, which is pretty good. However, the algorithm turned $10,000 into $49,000, a 68% return for the bought and held compared to a 393% return for the algorithm. Pretty good results there. MHK is also a good one because there's a divergence. The MHK stock itself is down for the past 5 years, 2.6%, but the algorithm is actually up $23,000. So we turned 10 to 23, 131% return for MHK. WYNN stock, also a good one, down 16% in the past 5 years. However, the algorithm was able to generate 111%, turn $10,000 into $21,000. DGX, same. The algorithm is up 177%. So we can also go back up and input these into the visualization to see where the buy and sell signals are. Of course, this algorithm is not perfect. Check out NVDA stock. You would have been way better off just holding NVIDIA instead of buying and selling it. NVIDIA, you could have turned $10,000 in the past 5 years into $198,000. So yeah, I'm kind of sad that I didn't own NVIDIA at the time. But the algorithm only returned $10,000 into $19,000. So we're comparing 2,000% return to 95% return. So this is a great example of the algorithm not outperforming the stock itself, and you would have been way better off just holding the stock itself. So, of course, the algorithm is not financial advice, nor is it perfect. But there are potentials with stock screeners in Python. You can automate processes, automate your stock analysis. You could use fundamental analysis with technical analysis. You can blend it with analyst coverage, analyst recommendations. You could potentially connect this with news sentiment articles. So there's a lot of potential with stock screeners in Python, and I hope this gave you a glimpse into what is possible with Python and the stock market. So I hope you enjoyed this video. If you did, consider subscribing to this video. Click on that subscribe button down below. And thank you so much for watching. Let me know what other videos you'd love to see on this channel. Check out my YouTube channel playlists for other option trading strategy videos and coding videos. And I will see you all in the next one.